and gear unit design, theory and practice. In this session, just a moment, please. In this session, I shall discuss about the few questions which you have raised in forum as well as in the recent, maybe yesterday or day before yesterday. Before starting the question answering, I would like to say this course was basically designed for final year BTech students, master students, and PhD students, and from the practicing engineers from industry also. So, if you are in BTech level, not in the fourth year, maybe second or third year, you may face a little difficulties, and that is why perhaps so many questions are coming. Now, don't worry, the questions, the final questions in the examinations and the assignment designed in such a way, if you go through all assignments properly, if you try to answer and later if you understand how we are answering, how to answer, then I do not think you will have any problem in answering in the examination. Now, another issue is there. Perhaps while I shall discuss your question answer, during that period, you may have some new question. Please note it down, or you are ready with some questions. Also keep those are ready. If I cannot answer within this session, definitely I will answer in few days. And you should also remember that we have final session, that is a second session on 10th of April, evening this time. By that time, you will complete the course. Now, to the best of my understanding, your 6th week is over. That means fundamental designs of gears and gear units is completed. So that is why I kept this good question answering session after the 6th week. Now, after this, there will be 2 weeks lectures. That is basically 10 to 12 lectures. That is on something special on the gears, that which I will discuss in the next session. So I think now I can start question answering. I am answering all forum questions which you have put in the forum and as well as in the recently for this session. Now, first one is that from, I think his name is Karthik. He has asked, what is gear tooth interference? Now, the answer is, during involute gearing, if teeth contact occurs beyond involute profile, usually one tooth with involute and other tooth is non-involute portion, then it is called tooth interference. This means that if you observe in gear teeth, the contact portion, which is called active contact, that means which take part in the gear power transmission, those are made involute. But root, particularly below the duodenum side, you will find that root is not involute. So if somehow the contacts come there due to say change in center distance other things, then it is called interference. Actually, the interference will occur if the teeth number is below a certain number. In case of 20-degree involute with 17, then while the gear is being cut, then say suppose if it is 16, 15 teeth is taken, it will be found that within the addendum portion, lower portion of the addendum, the involute is cut and some other profile is coming out, which is non-involute, and that is called interference. And due to that, what happens while gear cutting? That is called undercut. Okay, I think you have got your answer. Next question is by Akash Yadav. What is meant by term active in active profile generation? Now, this is active profile is called which takes part in power transmission or transferring the power. Now, you may find that whole involute may not be used for transmitting the power. Although the profile is involute, say from starting from the teeth to addendum, still it may not whole part is transmitting power. So which is not transmitting power, usually we shall not call it active. Active means it is transmitting power. So during this generation, active portion means you can say that with each taking part in cutting in involute portion. So, this is the understanding of active portion. Okay. Now, next question is from Sante S. Okay. What are the skills required for design engineer? Now, this is, I would say, that a design engineer should have very good knowledge of design, and they, as well as some knowledge, the basic manufacturing of the components, what he is designing, and then theory behind the design. And obviously, he should have very good skill in drawing also. This drawing, again, I would like to say, in case of industry, normally in general industry, you will find the who are the design engineers, they are making manufacturing drawing also. But in big industries like aircraft industry, machine tool industry, or like that, where precision job is done, and it is big industry, you will find the design engineers and the manufacturing drawing engineers are different. They manufacturing which making manufacturing drawing, he is having thorough knowledge, he knows the sequences and he will make the drawing accordingly. And in consultation with design engineers will mainly focus what he needs to perform the component. Okay. Now, which subject more focus the design engineers? I should say all subjects, because while you are going to design, you may need some knowledge of thermal also, you may need knowledge of heat treatment, you may need knowledge of kinematics, you may need knowledge of vibration, you may need knowledge of noise. So everything should be there. But here you should remember, one cannot be expert in all subjects. So if he is having the basic idea of the design, then he will focus only mainly focus on that what is the functional, which will fulfill the functional requirement, mainly stress level design and kinematic requirements. Now, in many companies, like say for example, aircraft industry, after designing, first it will may go to another group who is dynamics group, who will analyze the dynamics part of that. There may have another optimization group who will optimize the design. After that, it will go to the manufacturing unit. Okay. So it is very difficult to say. I should not say you should know this subject thoroughly, you will be able to be a good designer. It is not like that. If you have the interest on designing the engineering components, just go into that, start with your basic knowledge, then you will find, depending on the requirements and size of the company, there are many people who will help you. You may be expert only to have the new idea of the design and making the basic components, and then there will be another group who will give proper shape. So don't worry. So if you have whatever knowledge you have, jump with that. Which are the software skill required for design engineers? Now, I would say you may not have any software skill. Simply, if you can draw something on pen and paper, and if you can express your idea on papers, and if you have the skill of basic calculations, then you can produce your design. You can make your design. You can give it to some other person who is, suppose, good in stress analysis. He will do the stress analysis part, and it may go on like that. But nowadays, it is like that. We are mostly computer dependent. We are mostly on software dependent. So basically, I should say that you should have, say, some software like AutoCAD, and if you have some stress analysis and maybe 3D development, that will help also. I am not expert on that. I have the drawing knowledge. I know the AutoCAD, but I cannot develop a component in 3D. There are my students and other people who can do it. So with that minimum knowledge of the software, you can join as a design engineer. You can start your career as a design engineer. Which are the analysis software are more important? As I told that, there is, I should not say that you should know this. However, if you know some softwares, say like ANSYS and other things, which is for stress analysis, perhaps that might be helpful for designing the components. But there are many other software. You can go for some other analysis, say vibrational analysis or 3D development, as I told. So there is, I would say, I cannot specify something like that. But once you join in an organization, say for a design organization or in any industry or any institute or any research institute or even if the academic institute, you will find many softwares are there. You will automatically understand which you should learn, which you should pick up to run your desire, to run your job there. Okay, so I think you have got your answer. Now, next is that Gunjan Patel. He has asked a question in assignment 0, question number 21. The answer should be 80 RPM as the Q and R gears are mounted on the same shaft. No, I think you have misunderstood there. If you find that, if you justify this drawing, you will find the gear R is not connected to any other gears. Rather, you can find PRS is connected through Q. So Q is here idler gear. So direct ratio can be found out by the tip number on P and S. So therefore, the answer will be, because the input RPM is 4, that is RPM of gear P is 4. So RPM of S will be 400 into tip number of that P and divided by the tip number of S, which is 24 and 80. So answer will be 120 RPM. Okay, I think you will get it. This is, the figure is slightly confusing because the gear is not being used. Why it is there? But this was a gate question. Okay, in gate question it was like that. So we have directly taken from there, so that you can have that what type of question may have in the gate, and you have to answer in which way. So you have to clearly understand that what is what, which is transmitting power, which is not transmitting. Okay. Now, next question by Akshay Jadhav. He has asked, if in a operation where precision is required and the gears are to used in both directions, clockwise and anti-clockwise. In that case, how backlash is controlled? Now the question is that what is the purpose? Now, about in precision gears, say it might be machine tools, particularly machine tools where reverse and forward drive is required, or many other where in forward and reverse drive is required. If those gears are very precision and really it is required that we have to use for, say, in robots position control. In that case, the gears are made very precision as well as it is zero backlash. That means there is no backlash. Now, once we do not provide the backlash, what will happen? Due to the thermal condition, the size of the gear will increase or decrease. Okay. Now, due to that, there will be change in backlash. If originally backlash is given, then while we are trying to move in the reverse direction, there will be slightly false drive. To avoid that, particularly for robotics drive, where the positioning, etc., is required, really gear is made zero backlash. Now, what again means the zero backlash? Does it mean there is no backlash? No, I would say there is backlash, small, which may be in some cases adjusted, can be adjustable, so that at a particular temperature conditions, there will be no expansion or reduction of the size of the gears. So we can make zero backlash. But in normal cases, suppose in case of waste and others, where it is in ambient temperature being operated, we need not bother about backlash. Backlash is there given depending on the increase in temperatures, may get jammed, or in cold condition, there will be too much contraction. So general backlash will be given, and while it is being reversed, a slight false movement will not harm the operation. Okay. So I hope that you have got your answer. Now, next question, AK Dagger. He has asked, R is the capital R is the radius of outer addendum circle. Then what is R, small r, in the equation? This small r is nothing but the pitch circle radius of the gear. It might be the standard or whatever is there. This r means here pitch circle radius. Okay. Now, next question by him. What is the formula of calculating involute alpha value? 0.02475. I think he has given this value in radian. So if the alpha angle is 0.02475, then the involute alpha will be 10 of that in radian and minus this value itself radian, which comes, say, if you calculate 10 of 0.02475 minus 0.02475 will come 5.08205 e to the power minus 6, which means 0.0000508 and so on. Okay. So in that way, you have to calculate. Always remember, if you have some alpha angle or angle, any angle in degree, first you should convert it into radian. Then take 10 of that and subtract the same radian value, you will get the involute value of that. Is it clear? Okay, thank you. Next question is that this is from Madhav. The transcript of lecture 1 to 8 is not available on the websites. I think this is some problem was there. It was given. So already you have got this answer. So I think this problem is solved. Now next question by Jadhav again. Can we explain a bit more on how does manufacturing process and velocity affect tangential force and hence material selection? Now, this I would tell you. Now, depending on manufacturing, or I would say rather, depending on applications, first designs are made. So, general purpose industrial gears means usually gear will be hopped in case of if it is heat treated steel up to 300 VHN or so it can be hopped. If it is not heat treated, maybe it is up to 250 VHN. And general purpose, you can go for manufacturing it by hop. Now, in case of general purpose gears, the safety factor is taken in such a way this will not fail, even if there are some dynamic loads are there. We do not know exact purpose, general purpose is manufactured. But suppose a gearbox, general purpose gearbox, but it is being used for say crusher. In that case, lot of vibration will come to the gearbox. In that case, life of the gear may be less, and there will be also too much dynamics and as well as vibrations. Now, as far as the tangential force is concerned, the wind and the material, we select the material and we consider the design strength of it for gears. In that case, safety factor is taken in such a way that if there is some increase in tangential load, the gear will not fail automatically. Or in other words, it will not fail due to that dynamic load. Say it might be 2-3 times of the tangential load which you have taken. But suppose if there is very high load, then the gear tooth will break. Okay. Now, in that context, I would like to say also that what is gear failure? Failure doesn't mean that tooth is broken. Failure, normally gear is failed, we say that if you look into the gears are looking all right, the profiles are looking all right, but if you look minutely, you may find that surface are worn out even if there is pitting on the surface. In that case, we should say that gear is failed. That might be due to the increase in dynamic load. That means in the tangential load which you are talking about, maybe you are trying to mean that. That is so much fluctuation was there, the surface has pitted out. Normally, in case of industrial gears, if it is used with not much of unusual dynamic loads, it will long last. This will happen after a long time. Now, next question is from Pranav. Okay, I am getting 203 millimeters for question 4. I think this is related to some specific assignment, but it is not available in any options. Please help me proceeding to these questions. Now here I think that you have taken non-standard module. That is why it is coming something odd. Whenever you are calculating the module, you have to go for the standard module. I have given the chart. So for example, I think you have taken 2.8 where the close module is 3 millimeter. If you take the 3 millimeter, then you will find the size is coming what we have specified. Okay. Next question is by P. So, yeah, P. Shotto. How to find alpha and alpha dash and alpha in if not given in question. Now the question is that I think you are asking to find out alpha at a particular radius. Now, you should remember that once a teeth number of gear and the standard pressure angle is selected, that means which the cutter is having what the pressure angle. In that case, the base circle will be fixed. Okay. You cannot change the base circle. It will be a fixed one. Now, even if you go for the gear correction, that means the cutter is not fully deep or the teeth is more cut, still the base circle will not change. Now, if you have some known alpha angle at a known radius, then always your base circle will be that radius into cos of that pressure angle there. Now, usually for whether even if it is non-standard, you would know that alpha at pitch circle radius, standard pitch. Suppose you are considering a standard pitch circle radius, a standard gear, standard cut gear, a 20-degree input. Then suppose it is 100 teeth and module is 5. 100 into 5 divided by 2, that is your pitch circle radius. In that pitch circle radius, then what will be the base circle radius? That pitch circle radius into cos of standard pressure angle in this case 20 degree. So you get the base circle. Now, if you go to another R, at that R, if you multiply cos of alpha dash, say suppose the alpha dash is the pressure angle there, then that will be equal to your base circle radius. And from there you can calculate the alpha dash. That is shown, clearly shown. Okay, please go through that, you will understand. I think in assignment 1, the question number 14, if you check that solution, it will be okay. You will understand. Next question is that Plavon. Okay. I have a question about what is happening in lecture 3, laws of gearing kinematics, geometry part 2 as image attached here. Now, I think this is answer is that for a standard gear, no profile modification, no change in center distance, pitch circle radius equal to module into number of teeth divided by 2. That is why the calculation is like that. Okay. Now, I would say that what is pitch circle? First of all, if you see the standard pitch circle for standard cut gear, pitch circle is defined by the tooth number into module divided by 2. But in the same gear, you have say one standard pinion and one standard gear. Now, if they are meeting not at the standard pitch circle, say external gear, standard center distance. So suppose the external gears, in that case, center distance is somewhat increased due to some reason. In that case, working pitch circle will be different. How to find out that working pitch circles? That you know that base circles, those are standard. So consider these two base circles and draw a tangent to that, cross tangent through the central lines. In that case, intersection of the line joining two centers and that tangent will be your new pitch point. And then from there, from that geometry, you can calculate what will be the working pitch circles. Those are called working pitch circles. Okay. Now you have to do some exercise on that. You will understand better. Next question is Dharmath. Okay. Dharmath. Okay. Anyway, how do you solve the 9th problem in lecture 5 in week 1 You directly said that answer is option C. So can you please briefly explain it? So actually, I would say that now you have completed the 6 week. Once again, if you go through that, you will be automatically understand. I am not showing it separately. Still, if you cannot understand, you can write to us. I will send you the solution. Then next is that Akshay Jadhav. I have a question about what is happening in video. Some particular video I have mentioned. How did we get the relation among bones angle and teeth numbers? Now, this I would say this answer I will come later because there is similar question somewhere else, and we will go to this answer next. Now, another question is there by him. You mentioned about one gear is special case of 90-degree cross helical gear, and beta G is small, but at the 25th minute, you mentioned about cross helical gear with beta G, beta P is equal to 45 degree. Will this 45 degree configuration also in one gear shape? No, answer is no, because in one gear, helix angle of one is called as pitch angle. Now, this is actually one is like a thread. So in thread, there is a pitch angle and there is a lead angle. You can say better is called lead angle because in case of multiple start one, this will be the lead angle. This is like a thread. Now, number of teeth is small. In case of one, the number of teeth is nothing but the number of start. In many cases, you will find this is one. If it is a self-locking one gear, then it is one. In that case, you will find that angle is very small. So, the helix angle of the worm will be high. Now, I would say that this number of start usually 3, sometimes it is 4 also, which is not self-locking time. 3 or 4 means it is not self-locking time. Type. So that means if you rotate the worm wheel, the worm will also rotate. But in case of single start, if you try to rotate the worm wheel, you cannot rotate the worm. Now, if it is 3-4 start, in that case, the helix angle of the worm wheel may be around 75 or slightly more than that. And your lead angle will be very small, 9, 10, 15 degree or so. Okay. But in case of 90-degree crossed helical gear, you see this worm and worm wheel is compared with the 90-degree crossed helical gear. 90-degree crossed helical gear, suppose if it is for just transmitting motion from one direction to other direction, that's the vertical direction also, 90-degree direction, you can go for same number of teeth and you can go for 45 degree of helix angle, right hand in one and left hand in other. In that case, you should have teeth number, say for example 20 degree Untitled, at least 6 teeth, which is higher than the number of start of one. Now 6 teeth, how I have got it? If you consider the normative number of teeth, that is actual number of teeth divided by cos cube of the helix angle. So in that way, I have got this number close to 6. So I think it is now clear to you. Now, another question is that about what is happening in this video. So in that case, you have written, okay, this is ultimate strength. So one is the yield strength, another is the ultimate strength, and one is a design strength. Now, suppose a material, you have given a material which is only ultimate strength is given. Now, for steel, normally the yield strength will be, you can directly divide by ultimate strength by 2.5, or you can take 45% of the yield strength, you will be, sorry, ultimate strength, you will get yield strength. It's a rough estimation. Usually, while you are going to design, you should have clear data about what is the yield strength and what is the ultimate strength, etc. of this material. Now, again, in design strength, while you are trying to design the gear or any component, you have to consider the factor of safety. Normally, in case of general purpose gear design, to be in safe side, you can divide the yield strength, mind it, yield strength by 2.5 to 3. Whatever value you are getting, take that value as the design strength. That means that is in the formula of module calculations. Again, that is divided by some other factors, depending on lubrication condition and other. But whatever the design value is given, that can be divided by 2.5 or 3, like that. So depending on the applications, if it is a precision gears, this value may be less. So you should be careful about these two values. So I think you have confused somewhere, or might be in my lecture I could not clarify properly. That is why this confusion. So one is ultimate strength. To have the yield strength, you can divide by 2.5 or take 45% of the ultimate strength. If yield strength is given, then while you are considering the design strength, in that case, you should divide it by 2.5, 3, etc. Okay. Now, another question by him, assignment 2, question 1 solution. Oh, okay. This is about the cone angle of the bevel gears. This already there were some questions, so I will answer it. Somewhere, perhaps by mistaken, I have expressed tan of cone angle of pinion divide by tan of cone angle of gear is equal to teeth number of pinion divided by teeth number of gear. No, this is wrong. So in note it is correct. Actual expression is that tan of cone angle of pinion will be teeth number of pinion divided by teeth number of gear. Similarly, tan of cone angle of gear will be teeth number of gear divided by teeth number of pinion. This is bevel, straight bevel. Okay. Now, so this answer is given. Okay. So ultimate strength, this has. Now another question is that we can choose either of bearing side for locking. Yeah. The answer is that you can lock either of the bearing, two bearings on a shaft. So you can lock either side, left side or right side. But the question is that usually both the bearing will not take the equal load. It depends on, of course, direction of rotation. You will find one bearing is taking less amount of radial load. So if it is a helical gear, better you should put the axial load to that side. So for that reason, we lock that bearing so that axial load is always, or depending on the direction of rotations, the axial load is taken by only that side of gears. Okay. Say, you think in this way. Let us consider it is a spar gear, intermediate straight tooth spar gear. In that case, irrespective of direction of rotation or from same torque transmission, you will find the loads are one side is more, radial load is one side more than the other side. You will find that pinion side of the intermediate shaft, it is having one gear and one pinion. You will find that the pinion side radial load is more. Okay. Now, in that case, you need not lock actually, because ideally this should not slip. Okay, neither it is taking any axial, but we should not allow, due to the vibration, it may move this way and that way. So we need to lock one side. So in that case, you can lock any side. But if it is a helical gear, you will find axial load is coming. In that case, better to lock the gear side bearing, because it is having less radial load. Again, you will find the load capacity of the two bearings may be different, because you may have taken two different size gear. So you have to judge the equivalent load of these two bearings. You have to distribute in such a way that you are getting more life out of that. You should remember, in a gearbox, if one bearing fails, you should replace all the bearings. So that philosophy you should keep in mind. So now you can select which side should be locked or not. Okay. So I think you have got your answer. Now, again, another question by Dr. Jadhav. Instead of selecting one bearing on each side of shaft, can you use two bearings on each side of shaft of lower series? Next moment he had said, say lower series means, suppose a 63 series ball bearing was being used, and we would like to go for 62 or 61 series ball bearing, and instead of that you would like to use two bearings. Now, answer is that it is not preferred, because of the reason you always find, say suppose 6309 bearing. 6309 bearing is inside diameter is 45. Now you cannot change the shaft diameter, because shaft diameter is depend on the load and etc. etc. So you are now trying to go, say 61 series, 6109 bearing 45, and you would like to use the two bearings. Now, first of all, you will find the cost of that two bearings will be more than single bearing of 6309. So there it is ruled out. Secondly, even if you use two bearings, then there will be, say, four bearing support. Now, two bearing is somewhat you can call simply supported, whereas four bearings means it is somewhat more rigid. Rigid means there is no guarantee that all bearings are taking equal load. That means in one side two bearings, they may not be of equally loaded. And then in that case, you will find one bearing will fail to other. So these are not a good design. So go for single bearing one side, right? Of course, if you find that, suppose if your shaft diameter is 45 millimeter, 6309 bearing is giving too high life. In that case, if there is a scope, you can go for 6210 or 6110. That means shaft diameter is 50 and bearing life is slightly less and matching with others. Probably that type of exercise you can do, and that you have to decide of your own. You will automatically experience in this field while you are in design. Okay. Now, next question is that this question is that can you use OD of shaft as ID of the gear? This is by Dagar again. So no need of giving step in shaft. No, this is not a good design at all, because if you go for gear side shaft, you will find that steps are not there, then you cannot assemble. Say, for example, that while we are fixing the pinion side, then you will find that I don't know why you are asking this. It is not possible. Only pinion you may make integral with the shaft, but still in that case, you will find that root diameter of pinion is above the maximum shaft diameter in steps. Sometimes it is slightly below the maximum diameter. Usually pinion is one side, so maybe it might be slightly higher than the root, but gear cannot be integral with the shaft. Now next, other few questions which I have received yesterday. The gearbox design, please let us know lifting capacity of that. I could not follow. What is lifting capacity of that gearbox? What is lifting capacity? Please, your name is Ashish Kumar. You can again send a forum question on this matter, clarifying what is the lifting capacity you are meaning. Now, how do we select bolt size for locking cover plate on gearbox housing? This is a good question. I think this you are asking that how you can find out the bolt. Suppose if there is no axial load, then the bolt of the cover plate, main purpose of that, it is sealing the gearbox. Oil should not come out. So in that case, size may be small. Any size so that there is no leakage. Now, if it is leaking, taking the thrust load, particularly, suppose you are using bearings other than taper roller bearing. In that case, one side locking, suppose you have done for one side locking. In that case, the thrust load will go to the cover. Now, depending on thrust load, you have to design what load will come the bolt. Now again, usually you will find the gearbox size, this side covers are made of 6 bolts or in some cases 4. Rare it is 8 in there. Usually 6. Now why it is again 6, not 4, not 2? The reason is that if there is a space between 2 bolts, then middle portion of the cover may bend a little bit. So depending on that, so you are considering 6 bolts. Now, you can, depending on the thrust load, you can calculate what will be the load on each bolt. Then you have to follow the bolt design, you can see. But usually I would say, and on what basis, which shaft you should consider. So considering all such load, you select one bolt. That means all cover will have same size bolt. Same size means diameter, preferably same length also. And it might be 8 millimeter or 10 millimeter. You will find in normal cases, it will be 8 to 10 millimeter is good enough. 6 millimeter for small size gear. So for general purpose gear, it is not usually calculated. It is simply 8 millimeter or 10 millimeter bolts are taken, or for small gearbox, 6 millimeter bolt will be taken. But for if there is a very high load, heavy high thrust load, in that case you need to calculate, or in precision gearbox, automobile, aircraft, these are calculated. Okay. Now again, another question is that what are the common material we use in gearbox housing? How to decide wall thickness? Now, in gearbox, normally we will use the cast iron. Cast iron if it is a cast, or maybe mild steel if it is welded. Okay. Now, thickness if we think of the cast iron for general purpose casting, you will find the wall thickness is something between 6 to 7 millimeters. So if you keep the 6 to 7 millimeter wall thickness everywhere, except the rib and other portion, this is fine. And in case of MS, go for 6 to 8 millimeter thick plate and then you weld, it will be fine for general purpose gearbox. Now, if you find that you are making the gears, even if industrial gears, huge quantity, then you may find if you can go for smaller thickness, you will have more. You can save money in that way. So in that case, you should take the sample gearbox housing and you can go for stress analysis, say FM analysis or something like that. Now, another question is that vibration or noise level, how do we consider? Vibration or noise level depend both on application and manufacturing quality. Say, for example, if very rough gearbox you are using where the dynamics load there, it will have more vibration. But precision gears of that same dynamic condition will have less vibration. Now, so depending on application and manufacturing, those are considered. Or in other words, while you know the applications, you go for considering those in the design. But in general purpose, it is like that gearbox are made heavy. Those are put in good foundation, and there will be whatever vibration is coming. So that is within the tolerance limit of all components. If the vibration are more, life will be less. As I told that teeth will wear and there will be failure of bearing and there will be noise. So say supposing there are many cases where one gearbox is chosen for a particular purpose and then it's found it is not giving proper life, then with consultation with the manufacturer, we go for another gearbox. So these are automatically considered, not automatic. I would say that you have to carefully consider depending on the application. Suppose if you are working in a gear manufacturing company who makes the general purpose industrial gears a lot, and you are a sales engineer, then depending on the applications, you may offer a higher size gearbox if there is too much dynamics, etc., or adverse operating conditions. Now here I would like to mention, somewhere I found that there was a question about seam. What is seam? Now, as we are talking about the bolt calculations and vibration and other things, I would say that particularly in case of taper roller bearing, we have to tight the cover from both sides. Now, if it the proper amount of thrust load as well as maintaining the sealing may be difficult. That is why in that cover, some thin plates between the cover and the gearbox housing, some thin plates, even if some synthetic materials, it might be like the transparent paper what we use for the overhead projecting, writing things. That sort of papers, very thin papers or thin metal sheets, they are maybe in a number 1, 2, or 3. Those are used, and then those are tightened. After that, it's tested how much load is coming on that. So that is called seam. Somewhere some question was there on seam. So that is related to the question also, what would be the size of the bolts. Now, how to, I would like to mention that how it is, we understand that much load is given on the bolts. That is again, the tightening torque, depending on that. So in the torque range, that amount torque is fixed. So while we are tightening, automatically that load will come back. Then gearbox are tested also. After that, if you have 100 of gears, one or two gearbox you can test, and you can understand whether it is taking proper load or not. Okay. So now we are almost to close of that. Another 4-5 minutes.
Yes, sir.
Yes. Okay. Now someone has asked to. Someone means I think Ashish Kumar has asked to share the all gear drawings. So this is, I would say, that beyond the scope of this course. I have given only. I have shown him some sample drawing, how the drawing is done. Okay. So now if you join in design, I think they are having their own standard how to make the drawing. But always you have to keep the idea that how this component will be manufactured. So you have to put the dimension accordingly. Okay. Now, again, you are asking about that gearbox having helical, bifacial, and one gear. You see, this is a special case. All the gearbox are there. Say it might be automobile gears or gearbox in rolling mill and others. So this again, I would say, is a special thing. This is beyond the scope of this course. You have to learn of your own. When you will work there, you will automatically learn. You should follow the basic concept which I have given. Now, the automobile gearbox in design process is same for the industrial gearbox. I would say no. Answer is very much no. In automobile gearbox, more precision and high performance gears are required. And in that case, this is for lightweight and for specific line. Say, for example, aircraft gearbox or automobile gearbox, those are designed for a specific line. It might be say 5 years. That means considering that what is the average run in a year, say suppose one person will drive his car for a 50 kilometer per day, depending on that 5 years, what is the life. So in that case, you will find what the factor we are considering in designing, say yield strength divided by 2.5, you will find there it might be yield strength divided by just 1.5. That value is being taken. Again, the materials are heat treated and ground, automobiles or helicopter. Then those are first designed considering those values. After that, thorough stress analysis is done, and wherever it's possible, the size is reduced. If necessary, we increase the size a little bit to have the adequate strength. So those are all special cases. If you join in an automobile industry and if you will ask to design a gearbox, you will find the available data, available protocols are there. You can follow those. Okay, and also you can follow different standards. Now here again a relevant question that suppose if you go for FEA and FOS analysis, you will find that somewhere you can change the size also. So you can go for that. One can. If we rotate, next question is that if you rotate the gearbox 90 degrees such that input outputs have to become vertical, in such condition, will all forces calculated will be same? Answer is no. Answer is no. You have to, depending on the position of the gears and position of the bearing, and all will change. So in that case, load direction will change. So definitely the loads on the bearings will be different. Okay. And suppose the helical gear, you cannot simply make it 90 degree. So for a 90 degree input output gearbox, you have to go for bevel gear and others. And I think these are all the which I received. So I have discussed many things, but still you may have doubts. So do not hesitate to send the question to me, and we will definitely answer within this. And in the next session, we will again take up those and we will answer. And also, I take this opportunity to mention you that please do not ignore doing the assignments. if you want to pass this course, you have to have a pass certificate. In that case, you should independently pass an assignment also. And so you should do all assignments, as well as if you go through the assignments thoroughly, all the assignments, then I do not think it will be difficult for you to answer the question in a main exam. However, you need some skill for calculation because this subject is having many calculations. Okay. So thank you very much for listening. And in the meantime, you have some question. So I think you have noted it down. Please send it to me. And what I have discussed, I will try to send these all answers in a writing form, maybe within 2-3 days. So you can again go through. Okay.